Today we will see how to evaluate the integral secant cubed x dx. This is a very important integral. You will see this integral as a part of many other integration problems. In fact, this integral will be required material for the discussion planned for tomorrow in my channel. Alright, let's see how to integrate secant cubed x dx. I'm going to label this integration as integral I. What we are going to do next is we are going to split secant cubed x into secant squared x times secant x dx. And after that, we need to use integrations by parts. In order to use integrations by parts, we know we need to label one of those two functions as a function to be differentiated and the other function as the function to be integrated. Of course, we can easily integrate secant squared x using the standard results. Therefore, I'm going to label that function as dv. Of course, we can easily differentiate secant x. Therefore, I'm going to label that function as u. From integrations by parts, we know if you have integral u dv, this is going to be equal to u times v minus integral v times du, in which we integrate the function that was labeled as dv in order to obtain v, and we differentiate the function labeled as u in order to obtain du. Alright, let's write down the right hand side. The first term is u times v. U is equal to secant x times v. We know dv is equal to secant squared x. In order to obtain v, I need to integrate secant squared x. From the standard table of integrals, we know the integration of secant squared x is equal to tangent x. And then I have a negative symbol in the middle, minus integral v times du. V, as seen earlier, is equal to tangent x. Du, we know u equals secant x. Du should be equal to the derivative of secant x, which is secant x times tangent x. I already have a tangent x term here, and that other tangent x term that comes with the derivative of secant x will be combined with the already existing tangent x, and I'm going to write it as tangent squared x. And of course, this integral has to be evaluated with respect to x, therefore I'm going to write the dx term. Alright. Now, in the next step, what we are going to do is we are going to replace tangent squared x term using the second of the three Pythagorean identities from trig. We know the second of the three Pythagorean identities is tangent squared x plus 1 is equal to secant squared x. From that, I can subject tangent squared x as secant squared x minus 1. Alright, what I have to do next is I need to distribute this secant x term into each of these two terms inside parentheses. This is now equal to secant x times tangent x minus, since right here I have two terms, I'm going to write down this complete integration inside brackets. So let me open bracket, and then I will write down the first integral. The first integral is secant x times secant squared x, which is integral secant cubed x dx. And then I have this negative symbol, minus, for the next integral, I need to multiply secant x by 1. Then I get integration secant x dx. I'm going to close the brackets. Alright. What we have to do next is to distribute this negative symbol into these two terms inside brackets. Please also note that we have a secant cubed integration inside bracket right here. Secant cubed x term was labeled as integral I. That's what we did here. In fact, the left hand side of all these equations is equal to I. Also, this term right here is equal to I. I'm going to label that as integral I. Alright, let me write down all of these one more time. I equals secant x times tangent x, and then I need to distribute this negative symbol. The first term is I, therefore it becomes a negative I and then I need to distribute this negative symbol into that negative symbol right here. Then that next term becomes positive integration secant x dx. All right. Now what I'm going to do is I'm going to take this negative I on the right hand side into the left hand side. Then it becomes a 2i on the left hand side. This is going to be equal to secant x times tangent x plus integration of secant x dx, which is equal to natural logarithm absolute sign secant x plus tangent x. All right, now I need to subject I. On the left hand side I have 2i, therefore I simply need to divide both sides by 2. Then I get integral I equals 1/2 secant x tangent x plus 1/2 natural logarithm absolute sign secant x plus tangent x. Remember, this I is the integration of secant cubed x. Usually the integration of secant cubed x is found in the middle of some other integration problem. In case if integration of secant cubed x is given to you as a complete question, do not forget to add plus c, an arbitrary constant. All right, this is the complete answer of the integration of secant cubed x. This is a very important integral. Please make sure that you know it inside out. I hope you enjoyed this video. Thank you so much.